Hi, I'm going to solve this question on set-associative cache. And to begin this question, I'm going to highlight the most important pieces of information from this question that we have at the top here. Okay, a set of computer has a main memory which stores one cell per word. Okay, one cell per word, one word per line. Okay, it also has a four-way set-associative cache. That's important. Capable of holding 4 lines. An executing program reads data in 3 passes from a set of address sequences as shown below in decimal format. Okay, so we have 3 different passes. Show the contents in tabular form of each cache at the end of each pass. Calculate the hit rate for this example. Assume that the cache is initially empty and it uses the recently used cache replacement algorithm. So, show the content of the tabular form. We're going to show this by finishing off this table right below over here and calculate the hit rate. Okay, so for the first part, show the contents. So we need to have the pass 1, pass 2, and pass 3. Okay, and to calculate the hit rate, we're going to have hit rate for pass 1. Okay, hit rate for pass 2, hit rate for pass 3. Okay, and the other pieces of information that we need for this question are the cell number, the block number, and the set number. Okay, now for this question we also told that we have a four-way set associative cache. This tells me that the four-way say cache is equivalent to 4 lines per set. Okay, now these 4 lines that we have here mean that we have one set, which is set 0. Okay, so these 4 lines equal set 0. So for all the possible cells in block, they can go into 1, which is set 0. Okay, and for the different cells that we have 0, 1, 2, 3, and I'm only getting this information from the different decimal format numbers that we got at the top. They're coming from 0 all the way to 554, with 4, 5, 6, 7, 8, 9 being represented. Jumps out to 450, 448, sorry, to 449, 450, 451, 452, 453. And for the block number, since we have one word per line, that means we will have block cell 0 being block 0, cell 1 being 1, this being 2, this being 3, being 4. And this is just because we have one word per line. If we had 2 words per line, then these two will be block 1, right? But the question is 1 block per line, so that's what we have there. So we have 5, 6, 7, 8, 9. Oops, I made a mistake there. So we have 7, 8, 9, blah blah blah. 448, we jumped that. 449, 450, 451, 452, 453. I think we have a 454. Okay. Awesome. All right. The next step would be to start filling in the content. Okay. So we start off first with the first pass, and we start with this one, 0. To begin with, we have an empty cache, right? 0 will go, and just to make this simple, we'll begin with the first line of the cache, which is this one over here, right? And we'll also give it a timestamp just to keep everything in sync with this RLU rule that we got from up here. Okay, so this should be highlighted as well. And we have 0A, right? Okay. And our next one will come on to the next one, which is the next available line, 01, set, right? Line actually. And that will be 1B, right? We'll go on to the next one, which is the 2. Oh, right. 2. And we have the 2C there. Next one is a 3. We have a 3D. Right? Jump on to the next one. Now the next one is special because we don't have any more lines. So we need to make use of this rule. Right? And it tells us the least recently used cache replacement algorithm, right? And that tells us that we remove the recently used, right? The least recently used, which is A0. A0 gets removed and we have a place for 4. And since we're in the same set, we're still working with the same alphabet, right? We're still working with the same timestamp for that cache, right? In other words, so we will jump on to 4E, correct? And then we still don't have a pass for any yet, right? So we'll jump on to the next one, which is a 4, right? So the 4 will give me we'll cancel that and will give me a hit, right? So we have the first hit that we have, and we'll change the timestamp from an E to an F. Okay, we'll jump on to the next one, 5. 5 shows us that we don't have any we don't have another 5 in the cache, right? So we will have to find a spot for this in the 4 different lines that we have. But since we have the RLU to give us which will aid us in making our decision, we will say B because it's the least recently used. So we cancel B and we have 5G. Sorry, 5G. Okay, from F we go to G. Now our next one is a 6. 6, where will 6 go? Well, 6 will go over there after C, right? The least recently used, which we have as 6H. Next one is a 4. We still have a 4 in our cache, so we get another hit, right? And we cancel that, we give it a different timestamp, right? Since we have an H, now we have an I, right? 4. And now we jump on to a 7. Now a 7 is not there in our cache, so we need a different spot for it. Since we still have the D with the 3, we cancel that and we have 7J. Right, we jump on to the next one, which is an 8. We don't have an 8 in our cache, and the least recently used is the G, right? So we remove the G, we put the 8, and we have K, right? So K is our next one. So we have 9, right? We don't have 9 in our cache. So we remove the least recently used, which is H. So we have 9, L. And we jump onto the next one. We have an 8 already. So we have another hit. We cancel that. Right? When we jump onto the M. Okay. And now we have another 7. So we remove the 7. Since we have already a 7 there, we remove the 7J. And we have another hit, So we come from the M and we go on to an N. And this 7 has been used up. Right? So we jump onto the 6. Is there 6? No, we don't. So we have to have that 6 in. So to have that 6, we remove it from I in this case, because it's the least recently used, right? And we have the 6 come in. The 6 will have an O, right? Now we have 5 come in. Well, the 5 has no place to go, so it will have to substitute someone, right? And it will substitute the L, right? Sorry, 1 second. I will substitute the L, giving us the we have an O, we need a P. All right. Now for the 450, the 450 has no space to go to, so it remove the least recently used, and the least recently used is an N. It's an M. So that's 450, and we get from the N or PQ, that gets us a Q. We jump onto the next one, the 452. The 452, we're getting the list recently used since we don't have it. And that is the N. Just make that clear. The N. So we remove that. We have the 452. And that gets an R. Okay. Now the next one, 454. 454 does not exist. So we remove 454. We will remove the O, right? The 454. Remove the O. We have no hit rate still. So we'll jump on to the next one. Now before we jump on to the next one, it gets an S. The next one, we have the next one, which is 554, which has a hit. So we give that another hit, and that becomes a T. Okay. And we have done the first pass. And we have our pass 1 having 5 hits. Now our next pass, we'll start off by carrying over the different lines that we have from the previous pass. So we'll start off with 454, 455, and 452. Right? Okay. we'll also need to rank these in starting with a different timestamp. Okay. Beginning with the least. So in this case, the least for this one will be what is it? The Q. So the Q, no, sorry, it's the P. And the P would be A, and this would be B, P, Q, T, C. Sorry, actually, oops. This actually gets the C. Since it's R, S, T, this will get the D. Okay. And now to move on to the next one, we have the 450, right? So the 450 actually gets a hit. So the first thing, we actually get a hit since it's still in main memory, right? As still in our cache, sorry. And then 450 again. Now B, C, D, E, sorry. And then the next one again, we get another hit. So we jump on to F. 451. No hit. Remove 451, no hit. Doesn't exist in our cache. So we remove the list used, which is our 5, right? So we have the 451 there. And we have G, right? We remove the 449. The 449 does not exist in our cache. So list recently used, right? That's this one, C. The cache is the timestamp is coming in handy now, right? So we have 452. Sorry, we have 445. 445 coming in here, and it gets a timestamp of H. Our next one, 0. 0 does not exist in our cache, right? So we have to go to main memory to fetch that, and we will and where will we put it into? Which line will we put it into? That is determined by the RLU, which is RLU, which is the D. And so our 0 will get into an I there, right? Our next 0 will get a hit. So cancel that. We get another hit. We get a J. So that was for our next 0. And our next one after that, we'll get another hit. So from J, we get another hit. And from J, we jump on to K. Next hit. Our next one will be 1. 1 does not exist here. So we have to remove the least recently used, right? And in this case will be our F. So we remove our 1, and K will jump onto L. Next we have 2. 2 does not exist. We'll come on from F to G. This will become an M. We don't have a 2. We don't have a 3. Sorry. So we'll remove this one for H. And we'll jump on to 3M N. And our next one will be 0. We still have our 0 there, so that's another hit, right? So our K becomes from K to O, right? Okay, I should cancel that actually. And now our 2. Well, our 2 exists, so we get another hit, right? So our 2 comes from M to P, right? Our next 2 comes from P, we get another hit, and we get from P to Q. Next, we get a 0. 0, we get another hit. So removing that O, and we come from Q, we give it another R, right? And then we jump in from 0, we go to 1,